Hey everybody, Bill Sky the Rust Guy, and what we're going to do today is we're going to talk about keyboard input in Rust. Now there's going to be some more advanced stuff in this simply because Rust is kind of a complicated language. I'll get some arguments about that, but that's okay. That's what we're here for, is to talk about programming in Rust. So I've got Mint Linux up here running. You can do this on Windows, you can do this on any other Linux that you want to use, if that's what you want to use. You can even do it on a Mac. But what we're going to do is we're just going to do some example coding of some new of data input from the keyboard. So let's get right to the code. Okay, so I'm going to go into my folder here, my Rust projects. There we go, right there. And I'm going to go ahead and using Cargo, I'm going to create a new thing called, I don't know, project called keyboard input. And now let's take a look at the structure. Okay, there it is, keyboard input right there. And there's my source, and there's my main.rs. So I'm going to open that up with Genie. You can open it up with any editor that you like. I'm going to go to the terminal on Genie. I'm going to set the path from the document, go to the parent folder, and I'm going to say cargo build. And there you go. So what that's going to do is that's going to create a target debug folder. So I'm going to say target debug. And I believe it was keyboard input, and the program works hello world. So you should get pretty used to doing this if you're following these videos. So let's actually go ahead and do some keyboard input. Now before I do that, I always like to, in all of my programs, I always like to say the program is ending. So I'm going to say program ending. And again, for those of you that don't know why I do that, it's because so I can know that the program actually reached the last line of code, that it actually got to the last line of code, that there were no problems, I don't have to look at any return codes. It printed program ending, program ended. Okay, so let's go ahead and create some variables. So let's first of all just create a string variable. So I'm going to say let mutable username equals a new string. So let's do username. So we're gonna do strings, we're gonna do integers, and we're gonna do floats. So let's go ahead and create some variables for those. So I'm gonna say let mute and int string equals string new, and we're gonna talk about why I'm making my integer a string. We're gonna talk about that in just a moment. So let's do the same thing with float. And then let's go ahead and create some actual integer value variables. So I'm going to say let mutable and int integer 32-bit. Now this is a signed integer. We're going to make that equal to 0. And let mute a float, 32-bit float. You can use 64 if you want, but I'm just going to use 32-bit for now. Okay. So I mentioned earlier, or I showed earlier, that I went ahead and created a string and a float string. Now I could use any string for that. I could even use the username string if I want. But I decided to create two separate strings. And the reason is because the read line function within the standard in IO library in Rust, it doesn't read into an integer, it doesn't read into a floating point variable, it only reads into a string. And so what we're going to do is we're going to read the user's input into those strings, and then we're going to convert them into real numbers, real integers, and real floating points. So we'll get to that after we do the simple string input. Okay, so let's go ahead and ask the user to type in their name, or let's have them do a name. Now, one thing that you do need to do at the beginning of your program, you need to make sure that you're using the standard IO library. So you need to put the use std IO library at the top. And now let's go ahead and just do it. IO std in read line. Now here's where it gets kind of syntactical. The argument that you send the read line function must be a handle or a pointer to the variable you want to read into. So in this case, username. So we put the ampersand mutable variable username. That's the address of username that we're sending read line. Now, there's something else that I haven't really gone through. There's a panic feature here called expect. If we don't get what we expected, we want to make available to the panic of the application. The operating system, the application is going to say, oh my God, something went wrong. We want to put something in there. So I'm just going to put... Now we're actually going to see this demonstrated. We won't have a problem when we actually enter a string, but possibly when we convert a string into an integer or a float, we'll have a problem. So you'll see that in there. But that's a very good programming practice in Rust to put that dot expect. Okay, so one last thing I want to do is I want to clear out... Well, actually, let's hold that for later. So what we're going to do is we're going to say println. Your name is, and then username. And let's see how that works. So let's go ahead and build it. Let's go ahead and run it. Okay, so it said hello world. Now, it's not really prompting me for anything, which is bad programming. We're going to fix that in just a moment. I'm going to say Bill Sky Rust Guy. And it seemed to work. Your name is Bill Sky Rust Guy. So that's how you input a simple string. And I really find this a lot more difficult than C++, cin or kin and count, cout, count, and also on Java. It's just, I think there's a lot of syntax here, but every language is different, right? So let's go ahead and do another one. I'm just going to have them type their name in again, and we're going to print it again. And reason I'm doing this is I want to show you what happens with readline. So let's go ahead and build it, and let's run it. So I'll say Bill Sky the Rust Guy. Okay, Bill Sky the Rust Guy. Now I didn't prompt it. We're going to fix that in a moment. Silly Billy. Okay, so I wanted to show you. Oh, that's interesting. So it printed, what did it do here? It said, hello world. I typed in Bill Sky the Rust Guy. It said, your name is Bill Sky the Rust Guy. And then it asked me to type it in again. This time I typed in Silly Billy. It says here, your name is Bill Sky the Rust Guy, but then it printed Silly Billy again. What happened here? Well, what actually happened was when I pressed enter on the Silly Billy, that wasn't actually replacing username, the username variable. It was appending it to the end. So when I typed Bill Sky the Rust Guy up here, it included the enter key, the \n. It included the new line character. So that's why when it printed, we got this blank line here. So when it printed it again, it appended, it stuck to the end, Silly Billy after the \n after Bill Sky the Rust Guy. So we got two things. So what I'm going to do here, and I showed this earlier, I'm going to clear that string before each one, before each input. That's actually a really good idea to do. So we're going to go ahead and build it. And now let's say, so Bill Sky the Rust Guy. Okay, and I'll say Silly Billy. All right, so much better. So the dot clear, that cleared the string contents of Bill Sky the Rust Guy. So when I typed in Silly Billy, it stuck it at the end. Now, if you don't want the \n, you can put in a trim, which we will do in a little while, but that's an example of how the read line actually appends. So I don't need to ask myself for my name again, so I'm just going to go ahead and delete that. And then now let's go ahead and prompt the user. So instead of just displaying, or instead of just having it ask the user, it didn't even ask the user, it's just a blank blinking cursor. I'm going to say print, and I would like it on the same line. In fact, I would like to say, please enter your name, colon, and then have you enter it in right next to that. So we're going to say, please enter your full name. And then we have the read line. So let's see how that works. Well, why didn't it print, please enter your full name? That's kind of weird. Why didn't it do that? The reason it didn't do that is because the println flushes the print buffer. It flushes the std out, the standard out print buffer, to the screen, because it does a \n, or for you C++ people, it does a end L. So it doesn't do that automatically. And if I go ahead and type my name here, and let's just say Bill, well, yeah, now it says, please enter your full name. That's really weird, isn't it? So when you're using a print asterisk or print banger, whatever you want to call that, you need to flush the print buffer before you do the input, before you do the read line. So what we're going to do over here is after I do the print, I'm going to say IO write flush, and we give it the pointer to the standard out, and I'm just going to say expect error flush failed. So instead of it just displaying having me enter it in, I would like to flush the print buffer to make sure that this is displayed before I do the input. So let's see how this works. Okay, please enter your full name. Awesome. And that worked out great. Now, do you have to do this flush? Well, you really don't. If I go ahead and comment that out and put a print ln here and rebuild it, you don't really need that flush. Please enter your full name. Notice how it did it right now, because instead of just print, I said print and L. So that actually flushed out the buffer and displayed it on the screen. But if you like to do things that are a little bit more, I don't want to say user-friendly, but design more sophisticated. In other words, you put, you have the line that's asking you to enter it, you have the prompt on the same line. You have to do that flush. And let's make sure my change worked. Yep, looks good. Okay, so that is something you need to worry about. You need to worry about flushing the buffer so you can display it on the same line. All right, so that's number one, and I'm going to mark these so I can keep track. Now also notice when we're entering the string, it actually does accept spaces. If you do a cin on C++, it doesn't allow for spaces. You have to do I believe it's a get line, maybe? I can't remember off the top of my head. It's been a while since, or it's been a couple of weeks since I played with C++. But yeah, so if you use the get line on C++, it'll allow that. But that's by default the read line on Rust. Okay, let's do entering an integer. Now, if you remember, I created an integer string, and I also mentioned that the read line actually reads text, and that's absolutely true. It does. It reads text. It reads a string. It doesn't actually read an integer. So what I'm going to do is I'm going to copy this stuff, and we're going to make some changes. I'm going to say, please enter an integer. And we're going to flush the buffer to make sure that we can print that onto the screen. And I'm going to read line, but this time I'm going to read it not into username. I could, but I like variables that mean something. I'm going to say int string. Instead of saying read name, or your name is, I'm going to say the integer you entered is, and I'm going to say an int string, and I'm going to clear it just because we're going to reuse that string. Okay, Bill, now please enter an integer. So I'm going to say 1, 2, 3. All right, great, 1, 2, 3, looks good. However, there's a problem here. I can't do mathematics on a string. So if all I'm doing is entering in a number and then printing it to the screen, this will work for you. But that's not what we use numbers for. We use numbers to do math. So what we have to do is we have to parse the number, or we have to parse the string into an integer. And that's a very interesting set of code here. So what we're going to do is I'm going to introduce you to something else which is a little advanced in this fifth video of this course, but it's something that's very useful. I'm going to use a thing called match. And for those of you that are C or C++ programmers, it's a lot like the switch in those languages. So I'm going to say match, and I'm going to say an int string trim. Now what .trim does, first of all says run a method, run a function within the string class on Rust called trim. And what that does is it takes all of the spaces and the white space characters off the front and the back of the actual text you typed in. So if I typed in space 1 2 3 enter, it would get rid of the two spaces in front and would get rid of the enter key or the \n at the end of the 1 2 3. So we're going to say trim, and we're going to say .parse as an integer 32-bit. So that's how we're actually going to convert it into an integer. But what I want to do is I want to make sure it converts correctly before I actually do anything with it, before I actually do any math on it. So I'm going to do that. So if that's successful, and we're going to talk about this whole thing in the future, I'm going to do the same thing again. Now I'm going to do it for them. Now that I know that it works, that it did convert it correctly, I'm going to convert it again, but this time I'm going to assign the result of that to an int, and that's the variable that we created up here. Okay. Now during the conversion, I may want to say .expect error parsing integer. Okay, so we convert it, we put it into an int. Now I can say an int equals an int times 2. I can do actual math with it. And I can say println to prove it is an integer. Here it is times 2. And then we're going to close off that OK. Now, if the match, if the an int string, if this code right here resulted in an error, if the result was not OK, we're going to say ERR. When I get into this, when I get into the match, we're going to talk about all of this OK and ERR and N and E later on. And I could create an open and close brace here as well. I'm going to say println error parsing. Oh, my fingers. Parsing an integer. And E is the error code. And then we also have to close the match. I did that in the wrong place. I like to comment my closing braces just in case they're really long. The amount of code in there is really long and it goes off the page. Okay, so let's go ahead and see if this builds. And it built just fine. All right, so let's go ahead and run it. Okay, please enter your full name, Bill. Please enter an integer. So I'm going to put 1 2 3. All right, 1 2 3. Oh, error parsing an integer. Cannot parse integer from an empty string. What did we do here? So, oh, I cleared the string. I'm not ready to do that. So let's go ahead and get rid of that, and let's put that within this block of code. Rebuild it. Ah, looks really good now. Okay, so the integer you entered is 1 2 3, and then to prove it. All right, great. That's awesome. So we entered. Now, one thing you might want to do here is when you print, and where is that right here? Right, you might want to say .trim. Let's see if this works. So you might want to trim the white spaces before the 1 2 3 and after it's with a \n, so you don't get this blank line here. Let's see if this will work. So we'll put Bill, 1, 2, 3, and now that blank line is gone. So because that's what the trim function does, is it gets rid of all the non-printable characters to the screen. It gets rid of spaces, backslash n's. I think it even gets rid of tabs and things like that as well. So you can use that trim function anywhere. Now let's type something invalid. So let's type 1, 2, 3, F4. And here we go. You see a panic. The program just died. Notice it didn't say program ending, have a nice day. Oh, actually it did. But what happened was the expect kept the program from actually dying. But it executed a thing called a panic, which means, oop, there's an error. And what it did was it printed the error parsing an integer. It did what I typed in up here. But then it also, well, actually it did this right here. It printed the error parsing an integer. And that's what the ERR was all about. So the match said, try to parse it. If it was okay, do this. If it wasn't okay, do this. And the program ended. Now, if I just did this right here, like if I did this right here, let's see what happens when I do that. And I'm going to put an invalid number in there. The program did not end. It didn't go all the way to the end because I didn't have it within a match OK ERR. It did print the error parsing an integer, but it also did a thing called a panic. So when you're doing a match and you try to parse it, it doesn't actually go into panic mode. It's almost like a try-catch in C and C++, or C++, I should say. So it's always good to catch your errors that way. So, okay, so again, I tried to parse it. If it didn't parse correctly, it did this block of code which printed my message. It also printed the error code, or the error that the language created. And we can see that right here. We can see it printed my error code right here, but it also printed E, which is invalid digit found in the string. How can you get around that? You really can't. Your program has to decide what to do if it finds that kind of an error. If the user entered something wrong, you might want to display to them an error message and then go back up in a loop and say, please try again. Or you could just end the program and say, hey, you're stupid. I don't want to deal with you anymore. So anyway, so you don't want to do that in your program. Okay, so let's go ahead and now do a floating point number. Let's input a floating point number. So that was entering an integer. Now let's input a floating point number. And it's going to be pretty simple. What I'm going to do is I'm just going to copy all of this code I did up here. And instead of saying enter an integer, I'm going to say enter a floating point number. Okay? And the flush is good. The read line, oh, we want to do it to a float string. Let's make sure that variable name is correct. It's not an float string, it's a float string. So a float string. And it says the floating point you entered is, and let's make sure we get that variable in there. We still want to do the trim. So everywhere we see an int, we're going to change it to a float. Okay, and I believe our variable is a float, so let's take everywhere we see an int and change it to a float. Now, this is pretty important. When you're parsing the string, you don't want to do it as an integer, you want to do it as a float 32. And you also want to do that on the match to make sure that it is going to parse okay. So we can multiply that by 2. So once you get this down, it's pretty simple. Okay, that looks pretty good. I got everything. All the integers are gone. I'm using nothing but floats. Oh, parsing float. That was just a display. Everything is F32. All right, let's try that. Okay, oh, and a float. That's on line 47. Where's that? I typed it wrong. A float. Okay, just got my variable name wrong. Okay, a float. Oh, look at, I'm trying to multiply. This is really good error. I'm trying to multiply a floating point by an integer. 2 is an integer. So we just have to put 0.0 there. That is one thing I do like about the Rust compiler is it does give you suggestions. It actually helps you code. So, all right, might be complicated, but it helps you code. All right, let's try this out. So my name is Bill. I'm going to say 1, 2, 3. There's my 246. Please enter a floating point number, 123.45. And there's my 246.9. So we entered a string, we entered an integer, and we entered a float. And you could also make these 64-bit. So if I wanted to change this to 64, pretty simple. I just change all of my casts to 64. Now with integers, it doesn't make that big of a difference, but with floating point, it might. Because the more bits you have in a floating point number, the more accurate it will be. All right, let's try to build it. Let's run it. That looks good. All right, excellent. One thing we didn't try is to make sure our error processing for the float is correct. So let's put an invalid floating point. So I'll say 456.7.78. And we got an error. Error parsing floating point number because I have 2 decimal points. And the error showed invalid float literal. All right, so that is keyboard input in Rust. I hope this helped you out. It's a very logical thing that you want to do when you're writing code, when you're starting a new language, to be able to input data into the program so then you can process it. The next thing we're going to talk about in the next video is we're going to talk about casting data. We did a little bit of that here where we took a string and casted it into an integer, casted it into a float. But what about changing something from an integer to a float or a float to an integer? We're going to do that in the next video, and I hope to see you then.